What's up, my incredible students? How are you doing? Welcome back to Emoji Economics. For starters, my name is Godwale Godwin, and you are likely to be seeing my face most times whenever you click on an Emoji Economics video. Alright, but that doesn't mean that you won't find other faces taking classes on Emoji Economics YouTube channel. Okay, so now we'll be talking about integration by substitution. In our last class, we were talking about to introduce ourselves to integration, we introduce ourselves to the 9 rules of integration, and we gave examples, So that means we treated 9 examples at least, and then you had 5 assignments, you had 5 questions, and we do something like that so that there'll be a kind of feedback loop between the teacher and the students. By the time you are done with the assignment, you leave your answers in the comment section. We go through it and then see if your answers are right or wrong. Isn't that cool? Yeah, that's pretty cool. Thank you very much for everyone of you that has been subscribing to this channel, has been watching our videos, listening to the kind of things that we have to say. Thank you very much. Thank you so much for recommending the MOG YouTube channel to your colleagues in school, to your students, maybe to your teachers. I don't know. Right, thank you very much. We are going higher, we're going places. We need you to continue to recommend our videos, continue to recommend this channel to other students out there that really need these things. We know that generation in, generation out, a lot of students have problems with economics, and this is a channel that gives you explicit explanations on many economics concepts: mathematical economics, microeconomics, macroeconomics, even econometrics. This is the 172nd video on this channel. Just go through the playlist and enjoy yourself. Now let's just get back to today's business: integration by substitution. Now there are 3 methods of integration that I know. There might be more, so I'm not disputing that fact. There might be more, and over time people might just come up with something. So who knows? You might be seeing this video in 2097, whereas we're in 2021. So by then there might be more methods of integration. So I don't know. All right. So methods of integration: we have integration by substitution. That's number 1. Then the second is integration by parts. And the third is integration by partial fractions. Now the thing is that we are not going to do integration by partial fractions because that is left to students in engineering department as well as mathematics. We only make use of those things that we need in economics for the time being, of course. So we're talking about integration by substitution as well as integration by parts. In this video, it's only going to be integration by substitution, and in the subsequent video, it's going to be integration by parts, of course. And I would love to have you around. Or won't you love to see my face? I don't like to see my face. All right. So we have 3 examples here. The first is to find integration of this, and the second, and then the third. Now there is something there's something I need to tell you that, but from what we learned in the previous video, for as many as attended that class on integration, we didn't bring something. This is a product, so we didn't do something like this then, and it is impossible for us to use those methods that we used then to differentiate to integrate something like this. All right. So what we just have to do is to find, okay, what are the ways we can do that? And that was how people came up with this. I didn't come up with them. People came up with these kind of things. Now, for you to be able to use integration by substitution, for you to be able to use substitution method, we have to. There are 2 products, right? So we have to make the one in the bracket, the one that has the constant. We kind of make it a u. We name it. We give it a name, a u. And for us to know if we could actually use substitution method, the differential of whatever is here, all right, must divide the other one here without, and leaving a constant, just a constant, not a variable. Now, by the time we differentiate this, I will show you what that means. Now, by the time we differentiate this, whatever we get must divide 12x squared and give us a single number. All right. So if it doesn't give us a single number, we cannot use integration by substitution to do it, and that is when we kind of look at integration by parts and so on and so forth. Now, what do I mean? Now, this is solution. All right. So we have the first question which says that we should integrate 12x squared into bracket x cubed minus 17 the x. So I think we call this u. Right. So u. This is essentially integration of 12x squared. Right. Since u is already here, so u. All right. Let me give it a power. Okay. Let me give it a power. U is power. Okay, let me give it maybe minus half. Okay, let me give it something like that. Maybe for minus half. Alright, the x. Okay, so we have something like this. So what we have to look for is we have to look for the x. There's a kind of manipulation. I'm going to show you that now. So if u Okay, u is just equal to what is inside this bracket, right? So x raised to power 3 minus 17. So du dx, if you want the differentiation inside this, of course, that's how it goes. It equals 3x squared and the constant disappears. Alright, so we now have to make the x the subject because the x is here. So we say that the x then is equal to, when you do your cross multiplication, by now we should know that is going to give us du divided by 3x squared. So we substitute this, that's where the substitution comes in. We substitute this into what we already have here, right? And by the time we substitute, okay, so let me write it in another place. So we have 12, we have integral 12 x squared. Okay, u is still here, u, then minus half. Then instead of writing dx, we write du, right? Du divided by 3x squared. Alright, so we don't have the x anymore. The thing that we see now is that 3x squared will divide this guy, and so we'll be having integral 4, right? To go 4 times. 4, then u raised to power minus half du, right? Now the issue is that if we add x, there would have been an x here, and then how do we differentiate x with respect to u? Alright, so that's why I was saying that by the time you want to use substitution method, by the time you do the division, you must make sure that what you are getting is a constant, because now it's not going to be with respect to dx, it's now with respect to du. Now I hope you understand that. So what we now have to do is we integrate this guy. Okay, so by the time we integrate that guy, what are we going to get? So we have 4 will be outside, 4 will be integrating u raised to power minus half, right, du. Yeah, basically this was from one of the rules that we learned there, and this is going to give us 4 into brackets u raised to power minus half, right, plus 1 divided by minus half plus 1 then plus c, and that gives us 4u raised to power half plus 1 is half, right, half, then everything is divided by half, minus half plus 1 is half, then minus half plus 1 is half again, right, then plus c. So we can just extend this, okay, this is the same as 4u raised to power half, right, this is divided by 1 over 2, so which is left as multiplied by 2 over 1, right, multiplied by 2 over 1 equals then plus c. Okay, so you have 4u raised to power half divided by 1 over 2, so it's left as 5 raised to power half times 2 over 1, of course. So then that becomes 8u raised to power half, 8u raised to power half plus c. Plus c. So final, what we now do is, what was u in the first instance? U was s cubed minus 17. So final answer is going to be 8 into brackets s cubed minus 17 raised to power half plus c. So that's the answer. That's how to do integration by substitution. Right, so we can try to differentiate this and see if we are going to get this guy back. If we are going to get if we are going to get 12x squared x raised to power minus whatever. I don't think we should do it. Okay, we can actually do it. So let's say we want to integrate this. So let's say f of x. We want to differentiate this to see if we get that guy back. F of x equals 8 raised to power 8x cubed minus 17 then half. So I'm just going to use is it the quotient? No, that is not the quotient rule now. One of those rules. After product, we have one rule like that. I've forgotten the name. Anyway, so that's going to be half into brackets 8, half times 8, then you have x cubed minus 17. This is half minus 1. Then multiplied by differentiate this, you have 3x squared. Okay, half times 8 is 4, so you have 4 into brackets s cubed minus 17. Half minus 1 is minus half times 3x squared. 4 times 3x squared gives us 12x squared into brackets s cubed minus 17 raised to power minus half. Alright, so is that the same thing? We have it? Of course, you see. So that's it. Alright, so integrate, that's why we say integration is anti-differentiation. And we say that differentiation is anti-integration anyway. So that's that about that. Now let's move into this guy quickly. Number 2, we have integrate 4x into brackets x plus 1 raised to power cube dx. So what we just have to do basically is, the bracket is going to be u. So here is u, right? So here is u. So we have integral 4x into bracket u cube dx. So where u equals x plus 1, x plus 1. Now the thing is, by the time we do du dx here, du dx, we have a 1, and then, okay, let me just mumble up things together, and then dx is going to be du divided by 1, that is du. So we substitute that and bring it here, so it becomes 4x, 4x u raised by 3 du. And you see that x is still here. Now because x is still here, this cannot work. This cannot work. Okay, we would eventually be having 4. So instead of bringing the constant outside, so we'll be having 4 integral x u du. We can't do this. Alright, so because look at what we did here. For us to be able to continue here, we have to like divide this by this. We have the 4, took the 4 out, then we just have u, so integration with respect to du. But here, so we can't do u du because there's an x that is beside it, so this cannot be solved using integration by substitution method. That's why we didn't have to solve up to this point, but I wanted you to see something. Okay, we initially just what we have in the bracket. By the time you differentiate this, you have 1. 4x over 1 is 4x. So I already knew before writing the whole thing out. But some of you need to you need these things to be proven to you for you to understand it. Of course, I have to prove it myself to understand it. So why not prove it to you to understand it? Now let me do this now. All right. So let me attend this question. Okay. Let's just integrate. Let's see if we can use integration by substitution to solve it. Okay. I hope I'm not rubbing off what I shouldn't rub off. So we have integral. So we have integral x squared divided by 4x cubed plus 7, right? Plus 7. Then this is squared dx. Okay. So first, we basically know. Okay. Let me simplify it. This is going to be integral x squared into bracket from your law of indices 4x cubed plus 7 raised to the power minus 2 dx. So we're differentiating what is inside here, basically. And by the time we differentiate this, can you divide x squared and leave us with a constant? By the time we differentiate 4x cubed, we have a 12x squared, right? 12x squared. So x squared divided by 12x squared will give us a constant, a number. Okay, so a number without any other variable, which means that we may continue with integration by substitution. Okay. So we just say that u equals 4x cubed plus 7, just what is inside, such that this guy x squared 4x cubed plus 7 raised to the power minus 2 dx then becomes equals integral x squared u raised to the power minus 2 dx. Okay, so we have to look for du dx. So du dx from here is 12x squared, just 12x squared. The constant disappears, and from here dx, making the subject of the formula, dx then going to be du divided by 12x squared. So we substitute this guy dx here now. Alright, so we then have equals x squared u minus 2, then du divided by 12x squared. Now this here 1, this here 6. So we have equals integral 1 over 6, and u raised to power minus 2. Now from one of the rules, so 1 over 6 comes here, integral u raised to power minus 2. Alright, du, du power minus 2 du. Okay, so this gives us 1 divided by 6 into brackets u raised to power minus 2 plus 1, right? Divided by minus 2 plus 1. Then plus the constant term outside there. I hope I'm not mistaken. 1 over 6. Okay, so we have 1 over 6 into bracket u raised to power minus 2, that's u raised to power minus 1. Minus 1 divided by minus 2 plus 1 is minus 1, right? Then plus c, and this is equal to 1 over 6. Okay, this is going to be minus equals, because of this minus here, so we have minus 1 over 6 u raised to power minus 1 plus c. Alright, and we could just simplify this to be minus 1 over 6u plus c, because u raised to power minus 1 is similar as 1 over u, so it comes down. Now what is u? Okay, u is this person, so we bring it back. So integral x squared, into bracket 4x cubed plus 7. Writing the question is from minus 2 dx is then going to give us what we had here, minus 1 over 6 into bracket. What is u? 4x cubed plus 7, right? Okay, 4x cubed plus 7. Okay, the power here is minus 2 plus 1. Okay, the minus 1, then plus c, what's the constant term? So that's how to do it. That's how to do it. So we are done with this question. Now to your assignment. Please, if you don't understand anything that I've done here, don't hesitate to leave your questions in the comment section. So I would love to attend to them as quickly as I can, as quickly as I am chanced to do that. Okay. So your assignment for you to know if you really understand this stuff. Assignment is going to be, so you are going to use the substitution method to integrate this. So question 1, we have this. It looks long, but it's not actually long. 6x squared plus 4x plus 10 divided by s cubed plus s squared plus 5x plus 5x, right? This is raised power minus 3 dx. And question 2, I think there are just two questions. 2 equals 3x squared plus 2 divided by 4s cubed plus 8x. Wow, plus 8x. Can I make this a minus 2? I feel like making it a minus 2. Minus 8x plus 8x, then raised power minus 3 over 5 dx. Alright, so that's going to be your assignment. If you enjoyed this video, please make sure that you like this video. I didn't mention that for the first video. Like this video, please comment, leave questions, share this channel with your friends. You guys have been doing a whole lot, and I'm going to plan for you right now. Doing a whole lot. You're going to have achieved what you've achieved without you. Please make sure that you continue to share among your colleagues, among your peers. Don't hoard knowledge. If you are not hoarding it, that's why I'm giving it out for free. Please don't hoard it, to give it out for free. It's a university. You're having first class honors does not hinder another person from having the same honor. So it's not like a primary school where first position means the next person takes a second position. Please make sure you keep sharing. Let's make the world a better place. Thank you very much. And by the time we hit 1 million subscribers, we're going to be here together to congratulate each other or one another, as the case may be. Thank you. See you in the next class. We'll be talking about integration by parts. Thank you. Bye.